So welcome back. In this video we're going to be looking at some more exam style questions. So the questions you've been doing up until this point have been either multiple choice questions or part of a longer question. We're now going to look at the type of questions you'd actually come across in the exam. We're going to start the notes on page 12. So the first example. We're trying to find out the mass of barium sulfate that will be produced when we react barium chloride and copper sulfate together. The first thing we need is a balanced stoichiometric equation. Remember, we don't write word equations anymore. All of our equations are written using formulae. So we have copper sulfate, CuSO4, and we're going to react that with some barium chloride, which is BaCl2. You need to be able to work out these formulas. And they're going to react to form barium sulfate, BaSO4, and copper chloride, CuCl2. So both of these, we're told in the equation, are aqueous. The barium sulfate, we're told, is a solid, it's a precipitate. So my copper chloride is aqueous. And there I have my balanced equation. Now I need to work out the number of moles. Well, I've been given both the volume and the concentration of my copper sulfate. I've also been told that the barium chloride is in excess. So my limiting reagent must be my copper sulfate. So I'm going to work out the number of moles of that. So moles of copper sulfate is equal to my volume, 20, divided by 1,000, to change it into decimeters cubed, times by 0.1. So I get 0.002 of a mole of copper sulfate. Now the ratio between the copper sulfate and the barium sulfate, which is what I'm trying to find out, is a 1:1 ratio. From the equation, 1 mole of copper sulfate will produce 1 mole of barium sulfate. So I know I've got 0.002 of a mole of copper sulfate, so I'm going to have the same moles of barium sulfate. So the mass of barium sulfate is its moles, 0.002, times by the RMM of barium sulfate, which is 233.1 grams per mole. That equals 0.4662 grams, which to 2 sig fig, which is what my data has been given to, is 0.47 grams. Moving on to the second example, we tackle it in a very similar manner. So we're going to start by writing out the balanced equation. So I have calcium carbonate, CaCO3, and we're told that that's a solid, and it's reacting with hydrochloric acid, HCl, aqueous, and that will react to form calcium chloride, CaCl2, which is aqueous, and water, which is a liquid, and carbon dioxide, which is a gas. These are some of the equations that you need to know. So carbonate plus acid gives salt, water, and carbon dioxide. We do need to balance it up, and that means we need 2 in front of the HCl. So there's a 1:2 molar ratio between the carbonate and the acid. So we need to work out the number of moles of something. Well, we've been given both the volume and the concentration of the hydrochloric acid, so we're going to work out the number of moles of HCl, aqueous. So moles of our hydrochloric acid is volume, 25, divided by 1,000, times the concentration, which is 2, so that gives me 0.05 of a mole of hydrochloric acid. We want to work out the maximum mass of carbonate that will react with this, so we need to know our molar ratio. So our ratio between HCl and our calcium carbonate is a 2:1 ratio. That's the same as a 1:1/2 ratio. So I'm going to need half, or I'm going to be able to react half the number of moles of calcium carbonate as I've got hydrochloric acid. So therefore the moles of calcium carbonate will be half this value, so that's 0.025, and the mass is the same as before, moles times RMM, in this case is 100.1, and that will give us 2.5 grams, again to 2 sig figs. And our third example is looking at the minimum volume of sulfuric acid needed to react with a certain mass of magnesium. Again, this is one of these general equations that you're expected to know. So metal, magnesium, plus acid, in this case sulfuric acid, will give me a salt, magnesium sulfate, and will release hydrogen gas. So again, I've got solid magnesium, aqueous acid, aqueous sulfate, and hydrogen is obviously a gas. Again, I need to work out the number of moles of something. In this case, I haven't been given enough information about the sulfuric acid, I've only got its concentration, but I have been given the grams of magnesium, and as magnesium is a solid, I can work out its moles. So moles of magnesium is mass 0.24 divided by the RAM from my periodic table, which is 24.3, and I get my moles as 0.009876. Again, I'm going to keep that number in my calculator. The ratio between magnesium and sulfuric acid is a nice one because it's just 1 to 1. So therefore I have the same number of moles of sulfuric acid, or I've got the same ratio here. So I want to work out the volume. So I'm going to rearrange my equation because volume is equal to moles times 1,000 divided by the concentration. I'm just going to rearrange that little moles equation. So the volume becomes the moles, 0.009876, the number I've kept in my calculator, times by 1,000, divided by the concentration, which is 0.5, and I get 19.8 centimetres cubed. Because of that 1,000, I've got it in centimetres cubed. So the last one on this page, we're looking at, again, a carbonate and acid reaction. So I've got magnesium carbonate, MgCO3, and I've got HCl. And again, these are going to react to form a salt, magnesium chloride, and water, H2O, and carbon dioxide gas. Again, I need to balance it up. So I'm going to need 2 moles of HCl here. I'm told that this is a solid because I've been given grams. This is hydrochloric acid, so it's always aqueous. This will be aqueous. Water is a liquid, and carbon dioxide is a gas. Again, I need to work out the number of moles. Well, the only thing I have the number of moles of here is the magnesium carbonate. So moles of magnesium carbonate is equal to its mass, 1.25 over the RMM, which is 84.3, and that gives me 0.014928. Again, I'm probably going to keep that number in my calculator. The ratio between the magnesium carbonate and the HCl is a 1 to 2 molar ratio. So I'm going to need twice the number of moles of HCl as I've got magnesium carbonate. So the moles of HCl is twice this number. So that's equal to 0.029656. Again, keeping that number in my calculator. I'm working out the volume again. So the volume, as we looked at here, is moles times by 1,000 divided by the concentration. All I've done is I've rearranged my moles equation. The other way you can think of this is using units. So you've got moles times 1 over the concentration. So concentration is moles per decimeters cubed, so this will be decimeters cubed over moles. These cancel to give us the volume in decimeters cubed. You would then times that by 1,000 to find the volume in centimeters cubed, which is a more usual value when we're doing titrations. So my volume is equal to my moles, 0.029656 times by 1,000 divided by my concentration. My concentration is 2, given my question, and that equals 14.8 centimeters cubed. So that's how much HCl I would need to react all of that magnesium carbonate.